Hello, welcome back to Cracking the Cryptic during debut week, where we are giving debuts to at least 4 constructors on the channel. Now, that doesn't mean we're not doing debuts at other times, it's just that we've got a run of them going on in my slot on the channel this week. So this one is called Solver's Badge by Seren. I don't know much about this, but we will have a look at it in a moment. Let me just remind you about the links below the video to all the merchandise, the apps, the Sven SUDOKU pad, the Discord server, and Patreon, amongst other things. Also a catalogue of our puzzles. So you can check all the past puzzles, you can converse with people, you can get all our extra content on Patreon. It's all on the links under the video. But the first link under the video is to this puzzle, Solver's Badge. Now, I don't know if this is this a Superman badge particularly? Is the solver being Superman, or is this just a badge that the solver can wear? I don't know. It's an interesting design. I'll tell you something that's really interesting about this puzzle is it's completely symmetrical. How does that disambiguate? Well, it must be... Right, well, let's read the rules first of all. Normal Sudoku rules apply. Every group of 3 consecutive cells along a line must contain digits that sum to some multiple of 4, which may differ for different groups. Every group of 3 consecutive cells along a line must contain digits that sum to a multiple of 4. So those 3, every line is at least 3 cells long. Those 3 cells must sum to a multiple of 4. Those 3 must, those 3 must, those 3 must, those 3 must, etc., etc., etc. Right, digits in column 1 indicate the column in which the digit 1 appears in that row. E.g., a 6 in row 2, column 1 means that row 2, column 6 contains a 1. So a 6 there says that in this row, the number 1 appears in column 6. And the same applies, this is 159 rules, so the same applies, so if we had a 2 in the 5 column, that means that 5 appears in column 2, and if we had an 8 in the 9 column, that means that 9 appears there in column 8 for that row. You can, of course, have the 9 in the 9th column, which is just self-referential and proves it appears in column 9. So that is 159 rules. I've never seen this rule about every 3 consecutive cells forming a multiple of 4. Sorry, if I didn't read it, the same applies to columns 5 and 9 with the digits 5 and 9 respectively. So I did explain that. I just may not have read the rule. Okay, that's interesting. I don't know how this is going to work, but those are the rules. Do give it a try on the link under the video. I mean, it's fascinating that this can exist with just a few lines and that rule set. And I've no idea how to begin, but I am going to start now. Let's get cracking. Right, I suppose what I do know is that there is something in common between every 3rd digit on the line. Let's just imagine that that was a 2 and a 3. Right, here you would need to make this up to either 8 or 12. So you would need either a 3 or a 7, which are 4 apart. And here you would need one of the same pair of digits. So maybe a 2 and a 3 wasn't... I don't know how to come up with a pair that's going to yield something different there, sorry. But okay, it's kind of about modulo 4, isn't it? There are 4 sets of digits. 1, 5, 9 are 4 apart. 2 and 6, 3 and 7, 4 and 8, which we've seen in some contexts. And yeah, they're going to appear every 3rd cell. So on this long line, okay, I'm going to start colouring it. Let's go red, blue, yellow, primary colours. Then along the line, it must go again red, blue, yellow, red, blue. What I'm colouring here is one set of these digits. Now there could be repeated sets of these digits along the line, but they must work like this, in that just as there, 3 and 7, if they were there, would have to repeat here one of those digits to make this maths work. I'm just going to leave that set of possible digits there. Oh, and there we go. Look in box 5. We've got those 3 yellows. So that has to be the 159 set. This is the break-in. That must be it. That is very, very flippin' clever. Now, so yellow is 159. Now, do we know what red and blue are? Probably not. Ah, they're different because they're both in box. Well, they may not be different from each other, but they're different from 159. Yeah, okay, that much we know. Now, do I keep focusing on those and the summing to a multiple of 4, or do I start looking at the 159 rules? Because it's probably not a coincidence that that is 159 that we've sort of placed in box 5. I don't know. What would 1 go with? We can just do this with 1 and it'll work the same for 5 and 9. So what are blue and red? Ah, well, now that we know they're not 159 again from box 5. So 1, 2, 3 would add up to 6. 1, 2, 4 would add up to 7. That doesn't work. So 1, 3, 4, they must use the 3, 7 pair and the 4, 8 pair. So blue and red are different because they've got to use different ones of those. And they're all from 3, 7 or 4, 8. So we can mark them up as 3, 7 or 4, 8. And within the blue, let's say blue was 3, 7. That's one of them. That's the other. So that's the first one. So those two are the same. Those two are the same. Doesn't help. Oh gosh, this is weird. Right. Okay, I'm not quite going to take these out, these little symbols, because I'm still using them, but I'm going to leave them there. They're not in the puzzle. They're just my aid memoir. Now, what can we do? Ah, maybe we can use the 159 rule. Oh, well, yeah, this is a set of 159, so no, I don't know what that means. Hang on. If this was a 1, it would mean we had a 6 in column 1. But if it's a 9, we have a 6. So 6 appears in one of those 3 places. And this is a 4. Right. Oh, this is really useful in this row and not in this row. Well, that's how symmetry gets broken in a moment. That's absolutely weird. Okay, but this is brilliant because this digit is either a 1, 5 or 9, and that means it's in column 4 in this row. So that means 4 has to appear in one of those cells, and that means this pair, which are either 3, 7 or 4, 8, are not 4, 8. So red is a 3, 7 pair. Wow. So I could sort of go up here and mark red as 3, 7, yellow as 1, 5, 9, and now blue is 4, 8. And I haven't got anything for 2, 6. I haven't got any of them. Oh, that's really weird. Right, so 4 appears in one of those. Up here, 6 appears in one of those, and that's one of this unknown set. That's not very helpful. So one of these is blue. If it's there, it's not forming a double in its box. That's fine. Okay, I've got to keep going on 159 logic here now somehow. Ah, look, 4 or 8 there. Right, that's perfect. That says where is 5 in this row? It's in either column 4, but it's not. So it is in column 8. So we get a digit. We get a 5 there. That's an 8. That's a 4. That's an 8. That's a 4. I'm going to get rid of these cells now because I think I have kind of learnt or can look at the grid to learn these groupings. So we get a 5 there. Now what does that do for us? One of these is an 8. Just trying to do some Sudoku because that often appeals to me as something that's quite useful. 3, yeah, I mean, basically we've done the maths on this central long line. Whatever these numbers now work out at, we've fulfilled the brief of the multiple of 4 business. Right, now we definitely need to do something else with 159 somewhere. Where's 5 in this box? It's not in those cells or there. Now, for 5 to appear here, needs 9 in one of these cells. Can't be there. So 5 could be there if there was, well, there can't be a 9 here. There could be a 9 here. So 5 could be there. There can't be a 9 here because there's a 159 triple in the box. Can there be a 5 in... No, there can't be a 5 here because there'd have to be a 7 here, and that's impossible because of this 3-7 pair. Can there be a 5 here? No, because there'd need to be a 7 here. So those can't be 5, those can't be 5, that can't be 5. And I worked out one of these can't be 5. It can't be there because you can't have a 9 here, so that's 5. Good grief, there's only one place for 5 in box 6, but that's really hard to see. Now, this is a 9 to make that a 5. Now, one of these means that one of these is a 1. Which requires that to be a 6 or that to be a 4. And the other one is a 5, which requires this to be a 6 or this to be a 4. So one of those two is a 6 and one of those two is a 4. Don't like doing pencil marking across boxes, but I might need to remember that. Now, there's a 5 in one of these 3 cells by Sudoku. And that is going to be referred to by a 7 in one of these 3 cells, and it can't be in those 2 because there's the 3-7 pair in the box. That's beautiful. So 7, 3, 7, 3. This is where 5 is. Let's colour that yellow. Now that must be yellow as a result. So that is 1, 5 or 9. Because it's 3 cells away on the line. That's kind of what we worked out at the beginning. Now, if that was a 5, we'd have a 4 here. That works fine. What do these two add up to? Do they have to be red and blue as well? They can't be red. What? Hang on, I'm going to write the numbers down again to do the maths. So let's assume that's a 1. I'm trying to add these 3 up. 1, we're not allowed a red here because we've used up red in the box. So forget that. We can be, well, 1, 2, 4 adds up to 7. Oh, we could use yellow again. Yes, we're going to have to use yellow again. 3 yellows would add up to 3. That's no good. So 2 yellows plus this unused one. So these are yellow and purple. in some order. So are those two. And they're made up of numbers that are 159 or 26. Okay, that's all right. That works. Oh, I nearly threw myself badly there by not thinking you could repeat a colour on these lines, but you can, or in the sets of 3. Oh, now, 8 was not one of those options. They're 159 or 26, so that is not an 8. And we can place 8. What is this? This is 159, 2 or 6. Putting 5 in one of those. Well, it's not 9. No, I don't really know. Okay. This isn't necessarily yellow, nor is this. Okay, I don't really know how to resolve which one is yellow and which one is purple. And I haven't got any digits on this line yet. You kind of need a digit on the line to make it interesting. Maybe I'm missing. Okay, we've got 7 there. That put a 5 here. That's right. Now, where are the other 5s then in rows 1 and 2? In row 1, 5 is in one of those cells. So this is 1, 2, 3, 4, or 5, but it's not 3. This could be a 6. In fact, given that there's 2 yellows there, it's quite likely to be 4, 5, or 6. Okay, I'm missing the point here. 3 is in one of those 2 cells. 4 is not there or there, it's in one of those 2. Okay, so now I'm using this 4 once in that pair and once in that pair, which is a bit silly. Okay, I'm going to remove these cross border pencil marks because they will confuse me as we go on, and I hope I don't need them. 7, 7. We get a 7 down in one of these cells. 9, 8, 7. I was just going to observe that 5 can't be in column 7, 8, or 9 in these rows, but that's obvious from the fact they've been used up. Yeah, there is an interesting rule that each set of 3, like there or there, has to include 1 digit from 1, 2, 3, 1 from 4, 5, 6, and 1 from 7, 8, 9 to allow the normal Sudoku rules to take place, but I don't really see how that helps me here. Sevens in one of these 2 cells. What? I'm probably missing some very big obvious thing. Right, that is either a 1 or a 5. That was what was telling me that there was 4 in one of those 2 places. Not useful. Come on, think what is useful. We've got that 5 in column 7. Got this 9. Does that doesn't make this a 1? Sorry, I'm being very dense at this point. What am I missing now? Missing something. I'm quite pleased to get that that was a yellow-purple pair. I don't think I can do the maths on these. I just don't know enough about this line or these little ones. They're not really acting for me in any way. That 5 was a good spot as well. Right, if that was a 5, we would have a 4 here and a 1 here. This would be 2, 3, or 6. Well, it couldn't be 6 anymore. So it would be 2 or 3. Then we'd have a 5 in one of these positions. Well, that would make that not a 5, but that's obviously not a 5 anyway. Oh, this is column 3. And we cannot have a 3 in one of these cells because we've already had it in the row. So this cannot be yellow, because if that was a 1 or a 9, we'd be pointing at it from the edges with a 3. So that's not yellow, that's purple, that's yellow, this is purple, that's yellow. This is 1 or 5, saying that 5 in the row is in one of those two cells, so it's not there. That's 1 or 9, saying that we have a 4 in one of those two cells. This is 1, 5 or 9, saying that we have a 2 somewhere in these cells. Why is this not helping more? Purples are 2 and 6, so I can fill those in as possibilities. Wow, I'm really not seeing how to do this, am I? So let's have a look at this row again. Where are the 1 and 9 in it? Suppose one of them could be there, putting a 4 in the edges. I'm not looking at the right thing here. Come on. 7. That's a 5 or 1. So somewhere in one of those two cells we have a 6. We also have a 2 in one of them. Oh, let's colour these just in case that helps me understand anything. I don't think it will. Oh yes, where's 4 in this box? Good grief. There it is. So these include another yellow and a purple. That's all 3 yellows used up for the column. 1 purple, 2 blues. So we have 2 reds and a purple still to use up. That's a very odd way of looking at this. Ah, this can't be yellow because there's a 4 there. So that is yellow. It is a 5. I must learn that when we put a digit suddenly in the central column, or indeed the end columns, it's incredibly helpful. Look, now we get 1 and 9 there. This is definitely purple. It's 2 or 6. Now we got a 1 there, and I've learned now that that means I get a 5 to write in here. Let's make that yellow. So the 5 and 1 refer to each other. The 9 is in row 4, so we can put a 4 in there. That gives us a 4 in one of these two positions. I don't know which. 4, 1, 7, 9, 8. That can't be 4 anymore. So this is where 4 is in the central box. And that doesn't mean much for me. 5, 4, 8, 7. These are from 2, 3, 6. So one of these two is a 5. And in fact, we've got 5. Yes, this has become a 1 since it sees that 5. Yes, at the top. So 5 there, right. And these must help. That is in column 6. This one is in column 4, and something's gone wrong. Oh no. Okay, I'm really sorry. I'm going to wind back and see what I've done wrong. I don't think it liked me putting in the 4 in the middle at the top. Why did I want a 4 there? Because of this 4. I'd established that as an 8. This had to be purple. If that's a 4, it means there's a 5 there. Right, it was okay. It was fine. I was just a wally when I got to the 4. When I got to this being a 1, that's where I was a wally. Because I said that needs a 4 here. It doesn't. It needs a 4 here, where a 4 is fine. Sorry. Okay, so I was all right. I was just suddenly had an attack of the numpties. Bobbins. Right, so 4 there. We get a 4 in one of these 2 cells by Sudoku and a 4 in one of those 2. And those will be the last 4s in the puzzle. This has become a 5 in the central box. That means this one is a 6. That puts 3 here and 2 here, finishes off the central box. This is now a 3-5 pair, which means 5 appears there in one case and there in the other. So that's a 5-4 pair. Don't think I can resolve that. Or this 2-6 pair, weirdly, yeah. This is now a 1 or 9, saying that there's a 2 in one of those 2 positions. Oh, 5 in this row has to be here. And yes, as proved by that being a 2. So this is 6, 8, 9 as a triple. 3 is up here somewhere. Right, this can't be a 6 because there's not a 9 there. So it's 8 or 9. It's either self-referential or putting a 9 there. This can't be a 9 because it's column 7. This has to be the same, not parity, but modulo group as this one. So this can't be a 3 because that can't be 3 or 7. So this is a 5. Wow, and this is a 9. That gives us both of them, 8 and 6. I can colour them both yellow. I'm going to make that yellow because I can now see that's where 5 is. We get a 4 there, 3 there. This is self-referential, and that is saying there's a 5 in column 3. Yeah, that's fine. Sorry, I have to be very careful on this stuff because I am so capable of making a mistake. That is now purple or red. Now, what can this be? 1, 2, 6, 7, or 9 by Sudoku. But yellow plus red, so 5 plus 7 there is 12. This would have to be 4 or 8. That cannot happen. That cannot be 4 or 8. So that is not red. That is purple and is 2 or 6. 5 plus 2 would need a 1 here. So this is from the yellow group. That is 1 or 9. And that means that one of these is a 3. It means this is yellow as well. This is purple and is a 2. 9, 11, this is 1 or 9, and that means there's a 6 in one of these 2 cells, which is very lovely because they're both looking at this purple cell, which can't be a 6, and is a 2. That fixes 6, 2, 2, 1, 9, and 6 down here. This becomes a 7. 7 and 3 are red, it's well known. 2 and 6 are purple, 4 is blue. These are from, that's 1 or 7. Now, could it be a 1? Then there'd be a 7 here. So 7 is definitely in one of those cells. 3. Now, what about this? 1 yellow. I don't know. Yeah, I'm going to need more information, I think, to resolve that. Mind you, that is 1 or 8, because it sees all the other digits. That is 3, 6, 7, or 8. And this one is 1, 2, 3, or 7. No, maybe it's better done here. 5, 4. Oh, the trouble is that could be anything from any group except 4, 8. I don't know. I don't think these are the way to go. I don't think they seem very useful to me at the moment. So That is 1 or 9. Putting 9 either here. So if that was an 8, that would be 9, that would be 1. If that was a 1, that would be 9. Is that right? If that's an 8. No, that doesn't make that 9. That's nonsense. But if that's a 1, you get 8 here and 9 here. Yeah, that's fine. I'm not very clever at indexing puzzles. I find them very complicated to think about at all. Now, if that was a 3, you'd get a 9 here and a 1 here. If that was a 3, I don't know. One of those two's a 2. 1 is in one of those cells, so one of these is a 6. That's interesting, so that's not a 6. One's in one of those, so one of these is 7 or 8. That cannot be a 1, because that would be an 8. Oh, but 1 could be here, and that could be a 9. No, it can't. That's lovely. If you had 1 here, you'd have 9 here, but this cell would become impossible. So 1 is not in either of those two. It's in one of these, making there a 7 or 8 here. 1's in one of those two cells, so the 1 here is in one of these, and this is 1, 2, or 3. It can't be 3, so it's because of that, so it's 1 or 2. One of those is a 1. Sorry if it sounds like I'm just gibbering at the moment, but it is making sense to me. Now, if that's a 1, we have a 3 here. If it's a 9, we have a 3 here. In either case, this isn't a 3. Now, this has got quite reduced. This is either yellow or red now. Yellow plus red needs a blue, so that would be 8. Yellow plus yellow needs a purple, just looking at this one. So that would be 2, or it would have to be 6, in fact. It can't be 6, because 6 is in one of those cells. So this is an 8, which is blue, and that makes this red. Yellow, red, blue is a successful combination, and that must be 7. Wow, okay. I'm sure I've gone about this the hard way, but never mind. 5, 7, 8. 7, 8, 4, 5. There's a 6 there. That can't be 3. So one of these two is a 3, which puts 1 in one of those two, but we know it must be that one. So that's a 1. That's a 3. We've got 2, 6, and 9 to go. That can't be a 1 anymore. This is 6 or 9, which fits with that. 3 and 7 are in this group. So that's 1, 6, or 9, putting 1 in one of those positions, which doesn't help at all. 3, 5, 4, 1, 2. That's 1, 2, or 6. I couldn't just get a nice little Sudoku triple going, could I? Okay, if that was a 9, we'd have a 3 here. But if it's a 7, we get a 9 here. So one of those two is a 9, and this is 2 or 3. 6, 5, 4. Oh, I still haven't eliminated anything completely. Can I do this? It's too many variables. Right, 2, 3, or 7 is purple, red, purple or red. Purple or red. 1 or 8 is yellow or blue. So that would have to be yellow or blue if that was red, which would allow it to be 8 only. if this was purple, it couldn't be purple, yellow, yellow. So it would be purple, blue, 2, 8 is 10, and this would be a 6, which is purple. Double purple, yellow? No. Double purple, blue works. Yes, okay, 2, 6, 8, yeah. So let me just work that out again. If this is red, then that has to be blue or yellow, but the only one of those numbers that is blue or yellow is 8. And if that's purple, then with blue here, we're on to 15. That doesn't work because we would need 1, 5 or 9 there. So purple, yellow, purple, blue. I can't remember what I said. I'm just unbelievably unable to remember these. Purple, blue, 2, 8 is 10. That would be a 6. So this can only be 6 or 8. That's what I thought I was concluding. I don't even know how that helps. This is red, in which case it's 3 or 7, or purple, in which case it's 2. Sorry, I really am making a mountain out of a molehill on this puzzle. But I do not find it easy to see how to do these at all. I've almost certainly got some totally obvious thing. Let's see, if we got all the 5s, we've written in the numbers here, so they must be in columns 4, 1, 7, 6, 9, 2, 8, 5, 3. Yes, we've done all them. Now the 9s, we've got the ones in 4, 5 and 8. So there is a 9 here, which is giving us, which is signaled by a 6 here. That's not a 6. No, the 9s here are signaled by a 6 in one of these. So one of those is a 6. And there's a 6 there, so one of these two is a 6. That's just Sudoku. That needs a 6, one end or the other. Okay, the 1s, we should have a 5, a 4 and a 3 for the ones I can see. Yeah, that's okay. One of those is a 6. I have marked that already. That is a 1, 8 or 9, yes. This can't be 4, 5 or 6. Yes, that's logical from what we've got here. Or 3. So it's 1, 2, 7 or 9. Oh, I'm sure this is very straightforward at this point and I just can't see the right bit. Just looking at 9 possibilities there. 8 is in one of these 2 cells down here. So 2, 5, 4, 8, 6. 7 and 3 have to be in those. 1. This can't be a 2. That's 6 or a 9. That puts 1 in one of these 2. Don't see how that helps. This also can't be a 2 because that would put a 1 here. Oh, really? So this is a 2. That's also 6 or 9. So 1s are in little X-wings in these positions. Okay. So that's a 6, 9 pair. This can't be 9 and that can't be 9. So 1 is either there or there and is not here. So that must be a 9. That's self-referential. That gives us a 6 there, which gives us a 9 here. That gives us 1 and 6. That 1 means we get 6 here. Now, That is a 3, 7, 9 combination. In fact, 9 must be there, which makes this a 7, which makes this a 3. Then we get a 4 here, 1 and 8, and that 1 is correctly referring to that 9. Good. Now, 2, 3 pair there, putting 9 in one of those cells and one of those cells, which I think I knew anyway. This can't be a 3 anymore, which doesn't finish it off. That is 3 or 7. 1, 3 or 7 there. Please don't tell me I should just have continued the colouring and it would all have been straightforward, because that is not what I'm expecting. Now this can't be a 2, so that's not a 1, so that's a 6. So then we've got a 7, 8 pair. That becomes a 9. Then we get 1, 2 done there. Now I feel I'm finishing suddenly. 3 and 9. That's a 7 now. And there's a 6, 8 pair still to resolve. That has become a 7, and that probably fixes that line it's on. Let's just see if we get everything else free first. Rather, yeah, that becomes a 3 by Sudoku. That's 1 or 6. That's a 1, 8, 6 triple. So this is a 2. That's a 1. Don't know about this 7, 8 pair. Probably do. Yes, 1 is in column 7. Right. 8. 1 and 8. We get a 6 here and a 7 here and a 6, 8, 1 to finish. And there we go. Let's just correct the colouring on the ones where I have left half colours in. And I mean, you can, okay, let's finish off the colouring. For sometimes people tell me that that helps with their OCD, which I hope that's true. I'm not ever certain it's fully worth the effort in a way, because they probably find ways of coping anyway, I would have thought. But I do like to help people if we possibly can. So let's just highlight the colours and do them. 1 is yellow, 7 is red, 6 is purple, 3 is red, 2 is purple. This 9 should have been yellow, and that one should have been yellow. I've probably still missed something on the 1, 5, 9 diagonal, but it looks like everything's red, yellow and blue now. It looks like it to me anyway. There we go. That is a very interesting puzzle. I mean, I'm fascinated how the ambiguity didn't cause a problem. It's a really interesting solve, that. Thank you to Seren for sending it in. Very interesting puzzle. And well done to you if you got through that with a little more facility than I did. It's quite possible. Thanks for watching on the channel as always. Bye for now.